Okay, this is assignment 4.1. This is practicing implicit differentiation. This is the first couple practice problems. You should have done one for homework. If you did not, you should try it after what we talked about in the previous thing before you start the video. I'm just going to run through and do the problem. So here we go. So again, the idea is that I can take the derivative of left and right and not worry about the fact that the y is not where it's supposed to be, not y equals 2. Okay? So if I do that, the derivative of 2x is going to be, x squared is going to be 2x. Right? Plus, now here's where things get tricky. The y is not an x, so I can't just simply say 2y because that's not true. I'm taking with respect to x. But I can pretend like the pretend like the y is an x and use a chain rule, which means the derivative would be 2, don't change the inside, times the derivative of the inside, which would be the derivative of y with respect to x. And again, that's that moment where you go, oh, well, the chain actually gives me the derivative. If I know what the derivative of y with respect to x is, I can solve this expression. Okay? So again, the idea is, let's say I had 2x plus 3, or 2x plus 3, let me fix that. That's not going to work. It's a bad example. Let me fix that. So if I had x plus 3 squared, then the derivative would be 2x plus 3, because I can't do the derivative of this because I don't know how, but I can't take the derivative of the outside, and then to follow it on by taking the derivative of the inside, which would be 2 for that derivative of that inside. Same thing's happening here. I throw a 2 out in front of the y, because I don't know how to take the derivative of y, and then I tack on the end whatever the derivative of y with respect to x is. Now this is super handy because I'm actually trying to find dy dx. So I just start shoving things to the other side. 2y dy dx equals 2x negative. Just by moving the 2x over, divide by 2y, I get 2y dy dx equals negative 2x over 2y. And of course, the follow-on of that is that's just negative x over y. All right, that's how you do problem number 1. I hope that works for you. I'm going to leave it running for about 10 more seconds while you hit pause before you start problem number 3. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm going to select this and get it out of the way. Shrink it down. And again, you should pause this before you start problem number 3, because that's not good to do this without practice. Okay, so as I get ready to do number 3, here we go. It's going to be 1/2 x to the negative 1/2, as you figured, plus 1/2 y to the negative 1/2. Oh, but that's a y, and so therefore I have to tack on a dy dx, and the derivative of 9 is in fact 0. Okay, then just move things over. This is the same drill every single time. Y negative 1/2 dy dx equals negative 1/2 y to x to the negative 1/2. There you go. Sorry about that. And then I'm going to multiply both sides by 2 to get rid of those 1/2, because that's really bugging me. Negative 1/2 dy dx equals negative x to the negative 1/2. And then I recognize this x to the negative 1/2, so sorry, y to the negative 1/2, so I divide both sides by that. And I get my derivative. And of course, this is written really badly. We got a negative power on the bottom, and that means just flip it. So normally what we do is fix that up and go x to the negative 1/2 times y to the 1/2. Okay, and that would be the correct answer. Again, you can turn those into square roots if you wanted to, or do something like that. It's not necessary for the calculus. All right, maybe 10 seconds. So I'm going to count down, and then I want you to pause. I want you to try problem number 5. I want you to note the following. There's an x times a y. X times y, when you're going to do a derivative, means you're going to have to use the product rule. Okay, the product rule. This is going to be tricky here. So try that thing out, and then you should be in good shape. Again, hit pause. And 3, 2, 1. All right, I'm going to get this out of the way. Shrink it down. All right, now I'm going to do number 5. Number 5 is going to take a little bit more area. I'm going to go back to black writing. Go back to my dash, and here we go. So I got, so the x is easy, that's 3x squared, you know how to do that in your sleep, minus, now things get tricky. The first one times the second one. Derivative of y, well, if I pretend like that's the right thing, it would be 1, and then I have to tack on a dy dx because it's a y. Plus, now I'm going to take the derivative, so then it would be, I should be minus, my bad, because there's a minus sign in front of that xy, right? So minus the derivative of the first part, which would be 1, have the second part unchanged, which is just y, plus, and I take the derivative of this, again, the y is in the wrong place, so I just go 2y, then I have to tack on the dy dx as the chain, and that's going to equal 0. Okay, so that's the implicit differentiation part. The rest is algebra, but there's some tricky algebra, so we're going to play with this. So the rule we're going to go with is, and it's just going to be consistent, we're going to use it all the time. Consistent. So we're going to get the dy dx's on one side by themselves. And so that would be negative x dy dx plus 2y dy dx equals negative 3x squared. Again, I just subtracted that across, plus y. Again, subtracting the negative y across. Okay, now this next step, it's one you know how to do, but it may not occur to you to do it. And that is, I got dy dx in both of these. I'm going to factor out a dy dx. It's the same number. I'm allowed to do that. All right, and so all I did is I factored it out. I took it out of here, and took it out of here, and put it out in front. Okay? If I distribute it, it'd go back here, and it look just like where we came from. All right? Now, next on my list, I would look at this and go, okay, so that's nice. What do I do from here? Well, I've got this times this. I'm just going to divide the part I don't want across. So dy dx will be equal to negative 3x squared plus y all over negative x plus 2y. And that's my 5 minutes. Again, all that is, if you set it all up, you move you put the dy dx's all on one side, everything else on the other side, factor out your dy dx, okay? Then divide that piece across, and you're done. It works that way over and over and over again. It's the most common way these are done, and so you need to have that in your bag of tricks. All right, so that should get you run through 5. The next video starts with 7, and then has selected problems for the next worksheet, okay? So